In this video, we're going to talk about the graphs of logarithmic functions. So we're going to look at example 6. It says to graph f of x equals 2 to the x and g of x equals log base 2 of x in the same rectangular coordinate system. So first I want to just remind you that the f of x and the g of x are the y coordinate. So this is y equals 2 to the x and y equals log base 2 of x. So the first graph, the f of x, is one that we did back in section 9.1. So this is just a reminder. And we'll see how it's related to the log graph in a second. So we have x and then y is going to be equal to 2 to the x. So I'm going to do this graph in blue to match what the notes look like. And I'm just going to go from -2 up through +2. So -2, -1, 0, 1, and 2. I'm going to plug those in for x. So 2 to the -2, as you might remember, is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. So when I graph this, it's going to look like this. Again, this should be familiar to you. We talked about this and how this graph has an asymptote on the x-axis. So now we're going to do the log graph. So for this graph, I'm using the equation y equals log base 2 of x. I'm going to rewrite this in exponential form. In exponential form, this is 2 to the y power equals x. So this graph is going to be done a little bit differently than any graph we've seen so far. What I'm going to do here is I'm going to make a table of values, but this time I'm going to plug numbers into y, and then the answer that I get is going to be the x coordinate. So for y, I'm going to plug in again from -2 up through +2, -2, -1, 0, 1, and 2. I'm going to plug those in for the powers, and the answers that I get are going to be the x coordinates. So you'll see what's going to happen here is that this graph and the graph of y equals 2 to the x are going to have the same numbers, but the x and y coordinates are going to be switched. And as we learned in section 9.2, we call those inverses. So the graph of the logarithmic function and the exponential function are inverses. So we have 2 to the 0 here is 1, 2 to the first is 2, and 2 squared is 4. So again, I'm plugging these numbers in for y. I'm not writing it all out, but I'm plugging these numbers in for y to get the x coordinates. So on the graph, -0.25 for x, -2. That's going to be this point right here. 0.5, -1. We're going to have 1, 0. We're going to have 2, 1, and 4, 2. So 2, 1, and 4, 2. So the graph of the logarithm, as you can see, it has the same shape as the exponential function, but it's reflected over the gray line, which is y equals x, because the two graphs are inverses. So the logarithmic graph has an asymptote on the y-axis. Because it's going to get closer and closer to the y-axis here, but it's never going to cross it. So this is what the two graphs look like In my math lab, they don't have the ability to have you draw these graphs, just like they don't have the ability for you to draw the exponential graphs. So these are going to be multiple choice problems, but you'll see that in the homework. So you should look at checkpoint problem number 6. Again, go from -2 to +2 on your graph. Do this in your notes, check your answer, and then move on to the homework for the section.